Okay, well, if you recall in the last video on the idle air control valve stuff, which, by the way, if you saw that video, I ended up having to adjust it to 4.5 turns because 5 was just a little too much for my truck. Now, I do run a 170-degree thermostat, and I have a electric fan, so my motor might be a little different than yours. But I opened it back up and went to 4.5 turns, and I will, in that previous video, I'll update how that works. But I think that's going to kind of be where I want to have it for this motor. And in that video, I mentioned this little gizmo that I made. So you can see kind of what I did here. I took a piece of stainless plate and bent it here in my vise, and I'll put some photos of kind of how I fabricated this in case anyone's curious. Basically just bent it over some aluminum bars, and then I took the bolt that holds this bracket out, and I made kind of a little titanium stud affair so I could just bolt this on. And then you can see I kind of just got some screws here, and I guess I don't know if anyone else is going to be making this, but maybe I'll put the part numbers and stuff of the little screws and things I use. But this is a fairly common micro switch. You can find them all over the place. Now this particular one is made in Japan, so it's a little higher quality. I forget the exact part number, but I'll put a little spot in the video there and show it. In any event, if you look at kind of how this works, when you go full throttle on the throttle body here, you kind of get a little area where when you get to 95 or more % of full throttle, you can see what I've done there. I've set it up so that right when I go into full throttle, it clicks this switch. And you can see the switch has 4 leads running to the ECU and all over the place. And then I didn't want to cut into my factory harness, so I built like a little piggyback harness here that plugs into the factory harness. So if you look over here, this is the coolant. Maybe we can see it a little better this way. So this is the coolant sender for the ECU. And what I've done here is I've made a kind of a little harness that allows me to take the original connector that had plugged into there and plug it into my own harness. Now I'll dig up the schematic I drew and kind of explain it here in the video in a minute. But what is the issue we're trying to solve, or that I'm trying to solve with this contraption here? So with my motor, it's modified. I have a free-flowing head, as you've seen, and I port matched everything, and it's got a cam in it that's set for high RPMs, and I have an exhaust system and so forth. So I'm kind of at the outer limit of what the stock Toyota ECU can kind of understand. And so what this switch does, in essence, is when I go to full throttle, it tricks the ECU into richening up the motor. And so the reason I constructed this is because when driving my truck, and let me point out that I am running my airflow meter 1 click leaner. Now, and that kind of flies in the face of conventional wisdom, I think. If you look at places like LC Engineering, and by the way, LC Engineering sells a product that kind of it was the inspiration for this, and I'll get into that in a second when we go inside the truck. But the basic idea is this: if you make your 22R-E higher performance, higher flowing, bigger cam, bigger valves, whatever, and you say, well, now there's a lot more air flowing through the motor, and the stock Toyota ECU isn't really set up for that. So, as I said, conventional wisdom is you go in here and richen up the you adjust the clicks on inside the airflow meter to richen up the overall operation of the motor to account for that higher flow rate. And if you do it through the airflow meter, kind of what you're doing is across the entire range, you're tricking the ECU into thinking, well, there's more air coming in, therefore we need more gas coming added through the fuel injectors. And while that does kind of work, the downside to that is that it kills your gas mileage. So, instead of getting 20 miles around town, suddenly you're barely getting 17. And that's a pretty big price to pay for having a little extra horsepower. Now, on my particular truck, let's duck into the cabin here and I'll continue explaining some of this. Okay, we're inside the truck. So, let's look at this from what is the problem we're trying to solve. So, the truck, the ECU over there in the kick panel does a pretty good job of, maintaining a correct air-fuel ratio when you're just cruising along. And if you see my other videos, I have a wideband gauge down there, so I'm able to monitor kind of the different air-fuel ratios, pretty accurately, cruising versus wide open throttle, going up a hill, that sort of thing. So this all got kind of started because I noticed that when I would accelerate, to merge lanes, or if I wanted to kind of beat traffic on the highway or something, I noticed that under wide open throttle, if I quickly traversed from cruising to wide open throttle, my air fuel ratio would go way lean all of a sudden. Like I don't know what the actual air fuel ratio is, but I know lambda would be like 1.17 or something ridiculous. And so what would happen is the motor would go very lean because I believe the ECU was confused as to what in the heck is going on. And when it comes to the ECU, it basically has two modes, okay? It has what's known as closed loop, and then it has open loop. And closed loop, it's constantly getting feedback from the oxygen sensors, and therefore it's able to make, 1 second interval modifications to the fuel, and it does a pretty good job. And that's primarily for cruising along and getting good gas mileage. But when you go full throttle, my understanding is that the ECU has basically a map where it says, okay, this is how much gas we need under wide open throttle, and don't look at the oxygen sensors, just go with this table. Well, that table is designed for a stock motor, and if you've made modifications, when you go wide open throttle and you flip into that open loop mode, as they call it, then the ECU is relying on a table to run the fuel injectors that doesn't match the amount of air going through your motor, and that's why it will go lean, and you'll start to run into problems. So I didn't want my truck going really lean under wide open throttle, and also, in situations where I'm trying to go up a hill real fast or past traffic and merge onto the highway or something, having the truck get confused and go super lean basically meant a lot of hesitation and lag. So what I did was I wired in this little switch here, and what this switch is this is just a 5K potentiometer, which is wired into that little micro switch up there. So when I go full throttle, it basically is piggybacking in whatever resistance I've dialed in here on top of the signal going to the ECU from the coolant, the coolant sending sensor up there. And the reason that that's important is because the ECU in the truck is making adjustments to the duration of the fuel injectors based on the temperature of the coolant. So if I suddenly add in resistance, then the ECU says, oh my gosh, all of a sudden the motor's running ice cold. We need to pump more fuel in. Now, the motor isn't running ice cold. It's just that I need more fuel to achieve the correct air-fuel ratio under hard acceleration. And generally speaking, I want to see a lambda reading of around 0.88 to 0.91. And I'll put in the screen what the equivalent air-fuel ratios for gasoline is. But by adjusting this little potentiometer, I'm able to fine-tune basically the air-fuel ratio I get from the ECU when I give it wide open throttle. And it's basically an instantaneous situation, because the ECU is not relying on feedback data from, you know, a narrow band oxygen sensor that's only sending a signal once a second. So that's proven to be really great for kind of sudden acceleration and fine-tuning my air-fuel ratio as far as, you know, wide open throttle or heavy load kind of operations. And of course, it doesn't take a rocket scientist to figure out that when you want to make a lot of power, you got to have some gas going into the motor. So anyways, let me go back up to the front of the truck, and I'll kind of explain a little further, and then we can maybe look at some of the schematics here. All right, we're back at the front of the truck here. So as I showed before, when you go full throttle, what's happening is this linkage here is just tripping that little switch, and only when I get, you know, 98% of fuel throttle does it trip. Basically when I put my foot right down. But as I say, when I suddenly go full throttle, you know, I want to, in effect, kind of take over control of the situation and send a signal to the ECU that says, hey, we need gas right now. And so what I'm doing is I'm just tossing in some additional resistance to what's known as the THW lead to the ECU. And I'll put up some of the drawings and schematics and stuff. And as I say, this modification to the truck was kind of inspired by a little thing that LC Engineering had. I don't know if they still have it. Maybe they do. But it was, I think it was called like the Pro Tuning Module or something. I'll see if they still have it on their website. But it basically is just a little module, an adjustable potentiometer that you hack directly into the THW lead of the ECU, and it allows you to fine-tune the duration of the fuel injectors. The only thing I didn't like about their version is that it works universally, unilaterally across the motor at all times. And I wanted it only to operate under full throttle, which is when it's in open loop operation. When it's in closed loop operation, which again is when the ECU is taking feedback from the oxygen sensor, I want the ECU to be doing the fine tuning for me to get the best gas mileage possible. I don't want to just, blindly richen the entire fuel map when I don't need it. I only want that to occur when I need that extra horsepower, under full throttle, or, going up a hill towing a heavy load. That's when I want to make darn sure that the motor's running rich and not lean. When I'm just cruising along at 60, 70 miles an hour on the highway, there's not enough heat being generated from the motor for me to worry about, is it running at a lambda 1.0 or 0.95 or 1.05. And plus, my motor's ceramic coated inside as well, so it can tolerate a little more heat. Also, if you really study air-fuel ratios as it equates to dyno tuning and things, you'll see that there's actually a somewhat wide range of air-fuel ratios you can run. I want to say it's everything from 0.87 to maybe 0.93, where you more or less generate the same torque. Maybe a little less horsepower, it's hard to say. Okay, and I just want to cover, kind of for anyone who's interested on the fabrication side of things, how I made this little bracket. So you can kind of see this is some 304 stainless plate, 75 thousandths thick. I just made a cardboard bracket and super glued cardboard together until I kind of got it the way I wanted. Then, ended up using my bench vise here to kind of bend things. And I had some pieces of aluminum that happened to be just the right thickness for the bracket. So I just kind of bent everything over. And if you look closely, you can kind of see one of the tricks I use. I take a die grinder and cut on the inside of the bend a little channel to weaken the material just ever so slightly, and that promotes, bending in the kind of, way that I want it to. And you can kind of see here also in the final thing, you can see that little channel. It's not enough to weaken the material, but it's enough to let you get a pretty nice, 90-degree bend with a little bit of hammering and stuff and stuff. So that's kind of a handy little trick. So, and because it's 75 thousandths thick, I was able to just tap directly into the material and then use these 3.5 by 0.6 millimeter screws that hold the switch on. And this switch is just one. I think I got it out of a vacuum cleaner that I took apart or something. But this is the part number, V1561C25. You can search that online and find these switches all over the place. But what you want to be careful of is there's a lot of Chinese copies. And this one is the Omron switch brand. And it's made in Japan. And it's much higher quality. But you can kind of see the logic on it. There's a common lead here. And then depending on whether the switch is triggered or not, it just flips between, this lead or that lead. And that let me, and if you look at the circuit here, that let me design a little circuit where I built this little harness down here that plugs into the temperature sender on the lower intake runner of the motor. And I was able to kind of, depending on where this micro switch is, either loop in some additional resistance right here, and I ended up using a 5K ohm potentiometer, which I'll cover in a second. And then depending on whether this switch is triggered or not, I'm either allowing the resistance from the temperature sender to flow through normally on the THW line to the ECU, which is the line where the computer monitors the temperature of the motor, or under wide open throttle, it clicks in and it chains the resistance from the temperature sender and my potentiometer, wherever I have it adjusted, in series and presents those to the ECU. And so you can kind of see the harness I made here. And this is actually just an old temperature sensor that I hacksawed off and used some plastic welder and soldered in some leads. So that kind of lets me plug things in, but if I want to ever return it back to stock, I can just unplug it and plug the factory stuff back in. But if you kind of look at the ECU, for example, here, we can see, so this is the ECU for the computer, and you can see on its THW line, it's getting the resistance from the water temperature sender, and that tells the computer what the temperature is. And then what the computer does in return with that is, and if we look in the Toyota computer controlled system manual, we can see that the ECU has basically a warming up enrichment phase. And as you can see here, when the temperature is extremely low, and they're talking about the coolant temperature, this enrichment roughly doubles the injector volume. And you can see that the correction coefficient they use based on temperature is linear, and it roughly doubles the amount of base fuel that the ECU is designed to provide. So once the motor gets warmed up to 140 degrees Fahrenheit, you can see it drops off its correction coefficient. But if there were a way that we could trick the ECU into thinking the coolant is still cold, it will respond by widening the duration of the fuel injectors, and that's exactly what I wanted. If you look over here as to kind of what is the signal that the ECU is relying on, we can see that it's a resistance in kilo ohms from this water temperature sender. And if you look at my drawing, here's that sensor, and then basically I'm adding in more resistance. I ended up just buying some potentiometers and to test with. I ended up using the 5K because that gives me a good amount of kind of adjustability, but still fine-grained tuning control. And so you can kind of see the deal here. When the motor is cold, this water temperature sensor, for example, at freezing, it's going to give a reading of around 8,000 ohms roughly, and at kind of normal, 68 degree ambient temperature, it's giving you around 4,000 ohms, maybe 3,000 ohms. And then as the motor heats up to 180, 190 degrees, it's just barely giving you anything, 0.2 of an ohm, I guess, or 200 ohms, I suppose, and since that's kilo ohms. And so by adding back in up to 5 kilo ohms of resistance by virtue of this switch and by virtue of being able to adjust the resistance here. And you can see I have it set halfway, so I'm adding in about 2,600 ohms of resistance under full throttle. So what I'm kind of doing here is I'm kicking it back to 2,600 ohms. So I'm kicking it back to around, maybe 55 or 60 degrees. And the ECU responds by saying, oh, well, we're not operating at 140 degrees. We're way back here, so add a lot more fuel. And since I have it wired in to only do that under wide open throttle, it basically allows me to, as I mentioned earlier in the video, it basically allows me to use this switch to fine-tune the exact air-fuel ratio I'm seeing under wide open throttle. And I have to give credit where credit is due. This kind of was partially inspired by this LC Engineering module they sell called the Pro Air Fuel Tuning Module. And it's basically, near as I can figure, it's kind of the same deal. It's just a potentiometer that you wire in. Now, if you look at the instructions on their website, you can see they also hack into the THW wire. But the way that their module works is it's always in the mix. So wherever it lets you, in other words, it lets you adjust the air-fuel ratio across the entire spectrum of the ECU. Whereas what I'm doing is reliant on only the switch to bring this into contention under wide open throttle. So when I'm just cruising, I'm returning control to the ECU, and however I have the airflow meter set. And as I say, I'm actually running my airflow meter one click leaner for getting better gas mileage. But then under load, I want it to immediately go richer. So I'm going in here and tricking out what the ECU is seeing in terms of its temperature and stuff. So and so far in my testing on the road, it's proven to work really exceptionally well. The result or the response from the ECU is more or less instantaneous, and that allows me to, hit the accelerator to pass somebody or merge onto the highway or when the lanes are merging. It allows me to hit the accelerator, and right away, I've got a lot of fuel and a more or less perfect air-fuel ratio for making optimal horsepower. And I have it dialed around 0.88, 0.89 lambda, which is kind of right on the rich side of making the best power for the motor. So it's worked really well. Like I say, I was originally going to kind of look into doing something with the throttle position switch, or maybe because there are some other, if you read this manual, there are some other things that the ECU looks at. But I figured, well, if this is how LC Engineering is doing it, let me look into this a little bit and see kind of how maybe I could get something along these lines, but not hack directly into the ECU by cutting the harness, but maybe I could make something I could kind of plug in and test. But it turned out to work so well, I'm just going to leave it the way I have it. But it is nice to have this kind of setup so that I can return the car back to factory if it's ever needed, or if for some reason I need to take this off and work on it. But so that kind of gives you a little bit of background on how I did it and what it's doing. Basically just tricking out the computer and tricking the ECU into thinking the motor, the coolant temperature in the motor is much lower, and therefore it under a wide open throttle it just dumps more fuel in, and that allows me to maintain kind of good gas mileage while cruising, but when I need the power, I can really dump the extra fuel in momentarily there. So anyways, that's kind of it. If you have any questions on anything I've covered here, feel free to use the comment section below, and thanks for watching.